A-level physics worksheet. A cyclist pedals downhill on a road as shown in figure 1. From rest, here it should be underlined from rest at the top of the hill and reach a horizontal section of the road at a speed of 16 meters per second. The total mass of the cyclist and the cycle is 68 kilograms. So this is a given, and we have a cyclist at the top of the hill. So the cyclist is moving down. Okay, he's riding the bike, the cycle. So this is the starting point at the top of the hill. It is the starting point, and it reaches down to a horizontal surface, right? Okay, so at the start he started from rest, it says, right? So if he started from rest, his initial velocity is 0, and when he comes down at the horizontal section, it says it has 16 meters per second. So the initial speed is 0 because he started from rest, and the velocity when he reaches the horizontal section of the road is 16 meters per second, right? It is 60 meters per second when he reaches the horizontal section of the road. And the total mass of the cyclist and the cycle is 68 kilograms, it says. So mass total is equals to 68 kilograms. Now we figure out all the givens. Now we need to solve the questions given because we know the givens now, right? So we wrote the givens like this. So the first thing we need to do before solving any problem is to find out the givens and to understand the problem. Without that, we can do nothing. So when we go to the question, the first question says calculate the total kinetic energy of the cyclist and the cycle on reaching the horizontal section of the road, right? It says to find the total kinetic energy. So as we know, kinetic energy is equals to 1 over 2 m times v squared, right? Yeah. So we know the mass, we know the speed at the horizontal section. So we have everything, just we need to put the numbers in the formula. All right. So which is equals to 1 over 2, the mass, the total, the combined mass is 68 kilograms, right? And the velocity square, when we square the velocity, now we need to square 16 meters per second. We need to make it squared, right? 16 meters per second squared, right? So after manipulating the numbers, we will find 1 over 268 is 34, right? It is 34, and 16 squared is 256, right? 16 squared is 256. So we need to multiply 34 and 256. Don't forget to put the unit in 256. It is meter squared per second square, right? When we square it, both meter and second will be squared. So we find kinetic energy is equals to 8704 joules. When we put it in kilojoule, it will be divided by 1000, it will be 8.704 kilojoule. Alright, so this is the answer. So it says the answer section here. It says from 2 marks, so just write on the answer section, right? Okay, so now we can go to the other question. It says the height difference between the top of the hill and the horizontal section of the road is 12 meters. Calculate the loss of gravitational potential energy of the cycle and the cyclist. Alright, now let us draw, because the first thing is to understand the problem, right? So let us draw it. So the cyclist started from the top, as we know it, from the top, and it came down to the horizontal section of the road, and the height difference is 12 meters. Look, the height difference is 12 meters, right? Now we are asked to find the loss of gravitational potential energy, because the cyclist started from the top. It has gravitational potential energy 1, GPE1, let us say, and when it comes down it will have GPE2, right? When it is at the top, it has higher potential energies and it is on the horizontal section, right? Because potential energy, gravitational potential energy, increases as we increase the height, right? So it means it lost potential energy. So gravitational potential energy 2 minus gravitational potential energy 1. This is a change of gravitational potential energy. This is a change. So as we know, gravitational potential energy 2 is 0, okay, because the height of the cyclist is 0 when he reaches at the horizontal section of the road. Alright, so negative GPE1 is equals to, as we know the formula of gravitational potential energy, it is mgh, right? So we know m, it is 68 kilograms, and approximately we can take gravity to be 10 meters per second square. So we took 10 meters per second square for calculation purpose, and we know the height to be 12 meters, right? So times 10 meters per second squared, that is a gravity, and then times 12 meters, that is the height, the change in height, right? Alright, so when we calculate this after manipulation of the numbers, we get a number, and that number is the loss of gravitational potential energy, and it is 8,160 joule. So this is the number, and we can change it to kilojoule as we change it in the previous question. Just divide it by 1000. Okay, so this is the answer. Okay, this is the loss of gravitational potential energy. Let us go to the other question now. It says the work done by the cyclist when pedaling downhill is 2,400 joule. Account for the difference between the loss of gravitational potential energy and the gain of kinetic energy of the cyclist and the cycle. So kinetic energy we found 8,704 joule, and potential energy we found 8,160 joule. We know the work done here given is 2,400 joule. Alright, so the kinetic energy and the potential energy are not equal here. As you see, the kinetic energy is much more than the potential energy. There is a difference, right? The kinetic energy is greater than the potential energy. They are not equal, right? They are different. The reason is that there is extra work done by the cyclist, right? The cyclist is pedaling, right? So he's doing some work other than the work done due to gravity, right? The gravity is doing work and also the cyclist is doing work. So the kinetic energy is greater than the potential energy because the reason is due to the extra work done by the cyclist. Alright, so the cyclist is doing some work, okay, and there is also gravitational potential energy, right? So if there was only gravitational potential energy, if the cyclist is not pedaling, if he's just letting the cycle go down with him, it will not be this number, right? But he's doing some work, so it is due to the extra work done by the cyclist. Alright, there is a loss of energy due to friction, right? The cycle is making sound probably, and there is also friction, so there is loss of energy. And we know potential energy, it is due to gravity, right? Gravitational potential energy. So now the question said, as we know, account for the difference between the loss of gravitational potential energy and the gain of kinetic energy, and we accounted for it, right? Right, we wrote the reason why they are different. We said it is due to the extra work done by the cyclist, by the student, right? So we finished this question and we wrote it like this. You have to write it on the paper, right? Now let us go to the other question. It says the cyclist stops pedaling on reaching a horizontal section of the road and slows down to a standstill 160 meters further along this section of the road. Assume the deceleration is uniform. Now calculate the time taken by the cyclist to travel this distance. Alright, now we need to again visualize the problem. The cyclist started from the top and he reached to the horizontal section. After reaching the horizontal section, he continues to move along the horizontal section for 160 meters. Okay, he reached here and he move and he reached at the final station, let us say, and he moved 160 meters, right? So when he started, his speed was 16 meters per second, because when he reached the horizontal section, we said its speed was 16 meters per second, right? All right, so now we find the time taken, but we know the final speed is 0 because it says the cyclist stops, right? It just stops. So its final speed will be 0 meters per second. So v is equals to 0. Alright, so if v is equals to 0 and if we have this all givens, now we know there is questions called questions of uniformly accelerated question, right? There are questions of uniformly accelerated motion. So uniformly accelerated motion equations, we need to find the one equation that allows us to find the time. So it is s is equals to u plus v times time divided by 2. So now we can find t, right? Because the three known are here and t is unknown. All right, so v is 0, so we can make it 0. So ut divided by 2, right, which is equal to s, right? So now we can crisscross it, right? We can crisscross it. After crisscrossing it, now we can put 2s is equals to ut, then t will be equals to 2s divided by u, right? It is 2s divided by u. All right, so when we make 2s 2 times s is 160 meters divided by u is 16, right? So when we divide this, we can get 20 seconds. It will be 20 seconds, right? It will be 20 seconds. All right. So this is the answer. So after reaching the horizontal section of the road, the cyclist moves for 160 meters for 20 seconds and it stops moving, right? Thank you very much for watching our video. This is the first part of the video. We can come back to other questions next time. Thank you very much for watching.